Hello, welcome. My name is James of Yard Guitars, and today we are going to be looking at how to draw ready for cam the John Frusciante Stratocaster neck. So let's get to it. So if you have actually missed the first video, don't worry. Basically, it's a summary of what we're going to go to in this whole playlist of how to design and make John Frusciante's 1962 Stratocaster. But for those who didn't see the video, the first thing you actually need to do is head over to my website, which is www.yardguitars.co.uk, and in the footer of the website you will see a link or a little hyperlink for downloads. Go to there and download the neck and the body Fusion files, and make sure you've also downloaded Fusion, which is a free bit of 3D CAD software as well. So now we can actually get into the CAD. So I'm not going to go through teaching people to suck eggs. Hopefully you've come to this video because you have a basic understanding of CAD and some experience with Fusion. So just for those who haven't, and it's a bit of a crash course, what we want to do is make sure that I believe, if I check, yeah, we are in inches, because the original guitar would have been drawn in inches, or at least plotted on paper in inches. So we're all working to the same units, otherwise it could be very messy, and some person's going to have a guitar that's that big as opposed to the correct scale. On the top sort of bar, we have our sort of sketch. So this will then prompt us for a plane or a surface to start drawing on. Now these have to be flat, but this is where the origin lies. So imagine when you're back to school, this is the 0, 0, 0 point of X, Y, and Z. And that is where I actually put the 12th fret, the center of the 12th fret, because it just then works, and we can do that with the guitar body, and then when it comes to joining everything up, everything will be a lot easier. But that's only what I do. But once we have selected a plane, you'll be prompted into starting the actual sketch. So we've got all our sort of creating tools, and there are some more. These are just the ones that I use most, so they're the ones I keep sort of featured in this top ribbon. Constraints, so this is trying to create a ruling, so to speak, between the lines that you're drawing. So for example, tangent is putting a straight line onto the edge of that circle, so it's touching but only almost coming off of that angle of that circle, depending on where that touch point is. Parallel, pretty obvious, you got two lines that are parallel with each other. Perpendicular, 90 degrees to each other. You can fix them, which will change the color of stuff, but often not really fussed about that. But we'll come through this and I'll talk you through it, so hopefully it'll be a step by step. And you can measure, and there are hotkeys for this, so you can hit hotkey I and then you get your measurements of everything. On the right hand side is your sketch palette. So if you do lose your way and you're really far from it, you can try and zoom in and find the your part, or you can just hit this look at, and then it kind of focuses you back onto it. And there's certain things you can hide, points, projections, and 3D sketches if you do want to hide those. But if you have a look at what I've got on now, make sure yours is similar, so then we're sort of playing from the same hymn sheet, so to speak. Now when you go to finish any sketch, in the timeline it will give you a sketch. Now at the bottom, this is the timeline, or what we refer to as parametric modeling. Means it's got a history, so you can actually go back along this and slide it and see along that timeline all the features that I've done, and you can kind of work back through that and then make edits if you wanted to, but we'll come to that a bit later on. So I'm just going to get rid of that blank sketch because we don't need it. So like I mentioned before, these are all surfaces. Now it looks like a 3D model, but it's not. And if we look into the ribbon on the left hand side under bodies, and you open that folder, you'll see lots of these sort of orange, don't know how to explain it, rings, hoops, almost like C-clips or something. These are individual surfaces, so you can see where this split line is. this is your individual surface, and you can see as you highlight them on the left hand side, each of those are nominated by a particular number. But this is where we want to be. So if we were to hide one, let's say the top one where the fretboard would go, now you'll see that there's an empty volume, there's nothing in it. So this is almost just a glass jar, but we can't draw anything from that really. We can't, it's not a solid model, and it can be a bit of a nightmare when you want to machine from that. Not always, but for this case it is a bit of a nightmare. So make sure all of the bodies are visible. We want to select them all like so, and then go up past solid and go into surface, and we're going to go to modify, and I have it prompted as my first sort of icon. Select that, and then hopefully it will say you've got 24 items and there's no unstitched edges. Now if there was, if I was to remove one, you'll get the edges highlighted in red. And this then shows how many free edges. It basically means that when you stitch it together, it can't be a solid because it's got a gap, it's got a leak in it. So to plug that up, we want to make sure everything's highlighted, then tells us that there's no unstitched edges. I'm going to hit OK. Now hopefully all of those bodies or surfaces that we had on the left hand side, this now goes into one body, and you'll see that it's gone from that almost open coiled orange clip, which is a surface, and it's gone to this sort of solid white version. Now this means it is a solid, and we can start manufacturing from that. This is what we're sort of imagining the maple part of the neck to be. This particular one, the 62 Strat, back then they were actually gluing their rosewood fretboards on top, so it didn't have a skunk stripe in the back. So what we're going to do is actually draw in the fretboard itself. Now there's a very simple way. You could, you know, put it to where it actually joins the neck itself, but there's a little trick that I've kind of learned over my years of doing this sort of thing. And what we're going to do is go back to the solid in the left hand corner and use the extrude. Now this does a cut or an actual bringing something out. It kind of works both ways. So I'm going to select that top surface, and I'm going to go 0.175, and the reason for that is because it's the thickness of the fretboard, but it's going to ask to join, and we don't want to do that. We want to make sure that it is going up, and we can drag this slider and it all becomes a bit of a nuisance. But what we want to do is 0.175 and go back down. But instead of join, and it brings those two features together as one body, we want to make sure we in the operation select new body and then hit OK. Now this is an imaginary fretboard on top. Yes, I know it's over the headstock, but that's going to be removed very shortly. So now that we've got the fretboard actually there, what I'm going to do is radius that fretboard. Now this is something that we can change. If you're not a fan of the real vintage tight radius, you can change it to a 12. Heck, you can change it to a 20 and really annoy a lot of people. But because we're doing John Frusciante's one, we are constrained to the features or the specs of his guitar, at least for this one. So what I'm going to do, I'm going to highlight that origin, and I want to draw at the heel of that neck. So I want to select the plane which is parallel to where I want to be, and then I want to hit under construct this sort of draw off or offset plane. So as we draw it back, it doesn't really matter too much. I think let's just go 6.5 inches, and then we know we've got a healthy sort of margin to then cut into it, so to speak. So now we've got this floating orange square. This is a plane. This is our like a drawing paper, so to speak. So we want to select it and create sketch. Now you can see it looks a little bit weird, and that's because we're looking at it orthographically, so there's no perspective to this, i.e. the further away something is, the smaller it looks. We're not getting that on this particular viewpoint. You can, but when you come to drawing, it can be a bit of a nightmare because you want to see everything true, as if it's projected onto one surface. So we've got our origin there. So we're going to draw a line, hotkey L, And you'll notice we've got the origin there, and I'm going to draw it downwards. And then what I'm going to do is draw a second line up. Now at the moment I want to try and snap it to here, so holding down shift key and the point of that line, we can then hit coincident and it will snap to it, and you'll see that it goes pink. Now that's because it's using something as a reference. That's great, we want that. And then if you roll out of it, you can see what's going on. It's this line projected onto a flat surface. So when we get lost, rather than trying to scroll around and go back to where we wanted to be, just hit look at, and then there you are. So I'm now going to draw a circle at the bottom of here and go right here. Now this is what I was meaning about this circle is now tangent to that edge of the fretboard, because we know the optimal sort of thickness of that, and that's where we want to sort of work from. Now this is kind of a random, you can kind of see this is the radius of that fretboard. Now because we're working as a diameter, I've done it in the past where I've mixed it up and I've made twice as tight radius. So although we're going for a 7.25 inch radius, you can see that's not correct, because that's a radius, not a diameter. So what we want to do is 14.5, and you can see where that is now leading over to these lines, and it looks a lot better. Now we don't want the full circle, so we want to make some cake slices, so to speak. And what I'm going to do is bring them up to about yeah, 20 degrees is fine, 20 degrees. And you can see what I've got there. Now the reason why I'm working from that center is because it's constrained, i.e. it knows it has to be vertical. So we can use hotkey T or the trim tool in the modify, and I'm just going to cut that, and you can see it's highlighted. Now we don't want that, we want to actually make only this top radius, the one we're trying to reference, is the actual solid line. So you can select the two outers, and what I use is hotkey X, or at least that's what I've used anyway, and it's the line type here. And it basically makes it a construction line, i.e. it's there, you can reference from it, you can draw with it, but it doesn't evolve into a feature. So this is what you should have. So if I finish that sketch, we're now going to go back into surface and go into extrude. And then I'm going to just drag that slider all the way through, otherwise it will come up with some issues. And let's say minus 27 inches, because then it covers the full body, the full length of that body. Then I'm going to hit OK. And then what I tend to like to do is body 68, body 69, body 70. Doesn't mean a thing. So what I'm going to do, I'm just going to double click and call that neck, call this fretboard, and then I'm going to call this 7.25 inch radius ref, for example. So what I really like about surfacing is that you can use these references to split bodies. So bodies to split, you can highlight it by selecting the actual part, or you can actually select it over in the body's ribbon over in the left hand side. So if I hit fretboard, and then you've got your splitting tool. Now what are you cutting it with? So again, we want to then select the radius reference. It will automatically ask to extend that splitting tool. In this case, it won't make a difference, but sometimes it can do. And then hit OK. So now we've then got this top piece here, and the fretboard is split into two. So that bottom one, if we hide that and then hide the radius, you'll see the radius is actually there on the neck. But it does give some weird sort of things going on at the headstock. That's fine, we're going to get rid of that. So now what we want to do is clean up where the headstock is, and this is relatively simple, but it looks more complicated than it really is. Now we don't have to create a plane to actually draw from, we can actually just use the origin, and we've got this center plane, which is one of them, X and Y, no, X and YZ, of course. So highlight that one, select in the plane or on the left hand side, and then create sketch. So this gives us a nice side view of that neck. Now we're going to want to draw in this sort of step down and transition, but where do we start that from? So if you go into the sketches, I've actually drawn and named all of the sketches that we have imported. You want to go to Headstock Plan. You make that visible by the little eye icon, and then as you look over it, you'll see this construction line here. Now these two lines, that's your 0 fret, so to speak, and this is the back of the nut. So there's enough gap there for you to actually slot in a nut. But this one is our the start of that ramping. So I'm going to use hotkey P or project, and I'm going to select that line and hit OK. Now I'm going to hide the headstock plan, and you'll see hopefully there is somewhere a little purple little dot there. So go back, I've selected the right off of this little gimbal, or you could just hit look at. Now you see here, that's where the dot. So I'm going to use a construction line. I'm going to draw up and then do 0.175 because I know that's the top of the fretboard. Make that into a construction, either by, I've used hotkey X or just the line type over there. And then I'm going to draw a circle, which I know is then 2 inch in diameter, but 1 inch radius. And I'm going to draw down and then across. And I'm probably just going to go 7 inches just to make sure that it goes beyond that boundary. Now, if you were to have it slightly come in and it didn't cut all the way through, you'll get errors come up in the actual surfacing or when you go to split that body. So according to my references, what I'm going to do is hotkey D or dimension, and I'm going to use this bottom line here, the underside of the headstock, and I'm going to do 0.54. Now this is based off a book that I have scanned and can probably email to anyone. It's a great like Bible, so to speak. So here we're going to do a line to the actual top of that fretboard, but I'm going to do just an additional one because I want to know, because sometimes it can cause issues if you're just on the like a pixel of it or an edge. Sometimes you just want to give yourself enough clearance. So here I'm going to trim away the rest of that, and it's given me silly buggers. So why has it done that? Why? So I don't know why it's gone blue. This tends to mean that it's undefined. So there's something here that isn't fixed down. Now I've just gone through it, and Fusion has done this in the past where I've noticed it kind of gives issues even though I've constrained it, i.e. given it all the dimensions so it can't move. But we're just going to kind of roll with the punches on this one. So we're going to go to surface. We're going to go back to that extrude. We're going to select that line. Now if you go to pull that arrow, you only get from one side. So on the extrude feature on the right, we're going to hit symmetric and hit what is it, whole length, I think. Anyway, and then I'm just going to slide that across to make sure it cuts through both sides of that headstock. I'm going to hit OK, and same again when we've done the split body. I'm going to hit split. I'm going to select the fretboard and the neck, and the splitting tool is going to be whatever body that is. We haven't named it just yet, but body 72, and hit OK. So now we've got quite a few bodies, but I'm going to hide these and that one, and now we're starting to look like a proper neck. We've got the fretboard that's correctly radiused, and it now blends in to here, and it's nice in transition, so that's pretty cool. So me and the wife have actually gone out for a little stroll for our mental health and all that. And that's a reminder to everyone watching the video that you do also need to take a break and think about yourselves. If you do pay too much attention and into the work, it can take its toll. So just a friendly reminder to go for a walk, stretch your legs, and then you can come back to the work with a fresh pair of eyes. So now we're going to put in the features for the headstock, or where the tuners are going to go. So we want to select that face, right click and create sketch. Now it kind of orientates what it thinks is going to be correct and suitable. Personally, I want to rotate this round, and again, there we go. And I kind of want it looking the same as what a draft plan on a technical drawing would be orientated as. Just makes me a little bit more comfortable with what I'm doing. So what we're going to do is draw a line, and I want to make it roughly parallel with that outer edge, and then highlight those two and make them parallel. Now sometimes it might know that you're trying to aim for that, and it might already sort of snap it to that constraint. If so, that's fine, but if not, you can select the actual the icon itself on the line, delete it, and then constrain it how you like. I'm going to dimension that. Now there are a number of ways to dimension a line, but if you were to do this point to point, it's not the full length of that line because it's on an angle. So what I'm going to do is turn it over to the side and go 4.845, and this is going to be the full sort of starting to finish of those holes. So my first and last one need to be drawn on those, and then we just, for now, just pepper in for along that line. Select all of them by holding down the shift key, and then we're going to go to our constraints and hit equals. This means that they are all the same diameter, and according to the sources it is 0.394. There we go, and you can see they are constrained. I'm then going to go 0.969, point to point again, so not along that way but along the line, 969, the length of that line, 0.969, 0.969, and then that one should also be 0.969. There we go. Now this is already dimensioned because it's the full length of it, and it's going to give it to us in brackets, but at least we now know it is equal to the rest of it. I'm then gonna, at the moment, if we were to drag it, you can kind of see it stays all fixed to each other, but it doesn't know where it's positioned itself all along that headstock. So I'm going to dimension along the line that we were parallel with, and that should be 0.457. Now this is all in inches, remember. And then along that headstock plan, where the nut is going to be here, I'm going to hit P for project. I'm going to select that line and go OK. I'm going to hide the headstock plan, and we've got this line here. I'm going to draw a line outwards, making sure it's horizontal, and then I'm going to go up. I'm going to hit the midpoint, and you can see it's kind of snapped it over, and it's the middle of that line there. So these two we need as, select those two as constructions, or hotkey X, or you can do it over here. And then this dimension should be 4.016. Now, how do I know this? And that's because the reference booklet that I have scanned actually tells me all of this in a very old scan of the original Fender drafts. So I would hope they're as close as we are ever going to be to the real thing. Now, the problem you may find is you pick up a Squier or a Fender, a Mexican, a Japan, or an American, they're never going to be all the same. But if the starting point at least is what we can be as closely accurate as possible, then that's great. sometimes what you'll find is that radiuses, or just generally where a human interacted with that component, it has changed how that radius should be. Might have sounded a bit too much, not enough. And so that's where the sort of differences may come from. And also, over 70 years of this guitar, they have made slight changes to it. So this is what they call like the thin headstock, and they particularly have the spaghetti logo, but that's a topic for much later down the line. Now I don't know why it's not made these blue lines solid, or black, sorry, but it is all defined. And a quick way to check is just kind of drag a few points, you know, drag a line, and if you can't move any of this sketch or anything, it's probably because it's fixed. So when we're happy with that, we can then go to our top ribbon over on the left hand corner, top left, sorry, hit the extrude, and I'm going to hit those 6 lines. And then we could just, you know, drag that slider all the way through, and it will automatically default to a cut operation, which is great. This is what you want. I personally, to make it a little bit more controllable and parametric, I like to go to the extent type and hit to object. Now the reason for that is if we were to make this headstock thicker, then this will automatically adjust. If you were to, let's say, cut it down that 0.54 of an inch, crazy number, and then change the thickness of the headstock, maybe slightly thicker, it won't cut all the way through, because that feature is defined by a certain dimension as opposed to a reference. So if that reference changes, it will automatically update. So another thing that I've forgotten to do is at the back end of the guitar, we can't cut 90 degrees or whatever corner that is. It just doesn't exist. These were hand routed or pin routed from a template, so we got to be defined by a radius of that cutter. So on our modify, we've got chamfer and we've got radius. We want to hit the radius, and because these are 2 separate bodies, they're going to give you 2 lines, which is fine. And we're going to go 0.25 because it's a 1/4 inch, and making sure all 4 edges are selected. There we go. So it's now looking a little bit nice and cleaner. So the final sort of stage is to hide the fretboard. So we've got the neck, and in this particular era of Stratocaster, the neck wasn't one piece and then they put a skunk stripe in. They actually did it from underneath the fretboard, and it was adjustable at the back end, at the heel end. Now this is where I'm going to change it a little bit. I'm not going to put in the recess for a single action truss rod. If you do want that, then hit me up and I can show you exactly how to do that. It's a little bit more of a process. Personally, we are in the modern age where we can get double action truss rods, and I am going to dimension this for a double action truss rod with that similar pin wheel with the what do you call it, flathead screwdriver adjustment attachment. With that, yeah, so I'm going to make that adjustment for a modern truss rod. Now this is where we're, you know, modern technologies, let's use it. So we've hidden the fretboard. I'm going to hit select sketch, select that plane, hit create sketch, and then we've got this line here, and we're going to use the rectangle with the dot in the middle. Now this means we start from the middle and we can grow outwards. So we want to try and draw this roughly to a slot, and I'm going to draw upwards to that line, making sure that it is vertical to the origin, and that way it doesn't move that center point. I'm going to make the width 0.25 of an inch, 6.35 mil, and then I'm going to put this to 18, and I'm going to make this flat edge tangent to here. Now what I am going to do is draw an extra line and put that at 1/2 inch just there, because we don't actually want to remove all the material, and that's because the truss rod attachment was retrofitted almost after the fretboard and truss rod were glued in. So there's a sort of tweak to this. So now I'm going to take that, and if I remember rightly, let me just check some references. Yeah, we'll do it at 0.91 mil, and that's because we're using a modern truss rod, and I don't know what that is in inches, but it'll tell me in a minute. So at the moment it's wanting to go up, which is not what we want to do. We want to go minus. So if we go minus 9.1 mm, otherwise it defaults to inches, and go OK. So this is going to be the channel for the truss rod. So then if we get, we could probably, back to the construction plane that we use for radiusing the fretboard, if we try and find that wherever it may be, there we go. So it's the second to last one. If we go create sketch, and then we're going to 0.236. So if we draw a line, make that a construction and go 0.236, draw a circle, and then it's 0.374. So this is what we're going to do manually afterwards, and then we can fit the truss rod in. So there is a little bit of pokey jiggery. I'll probably use a 3D printed jig, but you can manually measure this and cut it yourself. So I'm going to go to solid, go to the extrude, and I'm going to go up to select distance to object. I'm going to go to the back end of that and hit OK. Or am I? But then again, for clearances, maybe let's edit that feature and let's go minus 1.5, and that way we've got enough clearance for it, so as it goes in, give us a good clearance. Perfect. When we're looking at our guitar neck, we've got the truss rod and where it's going to go. There are sort of lots of ways you can mate the fretboard up to the neck when you're gluing. So you could be very lucky that if you glue the two up, you line it up correctly and it doesn't drift. And now my cat has decided to scratch the carpet. Stop! One alternative is, oh my god. One alternative is to actually, in the fret slots themselves, is to put two little veneer pins once it's lined up and gluing, then you can clamp it up just to be sure. Well, I'm going to be machining this on my CNC, so I'm going to put in some dowel points and they're going to sit in between the frets. So this is how I'm going to do it. Oh my god. Always remember to save your work. You'll get a little asterisk. Fusion's pretty good because of the cloud-based sort of formatting. It will automatically kind of like save what do you call it, crash reports and bits like that, but we want to be sure that we are saving, so make sure you hit save. Try and keep the file management as clean as possible. Hiding the fretboard, we want to select the surface underneath, and you can see we've got our truss rod in the way. So what I'm going to do is put that scale length. Now you can see where these individual dots are, and that's where the frets are going to sit. And what I want to do is make a reference of the bottom two, and then make a reference of the top two. Now the reason for this is so that we don't put a dowel position in the same point of where a fret's going to go, because one, it's going to snap the tools, but also you're never going to be able to put a fret in there anyway. So with those two at the top, I'm going to draw a line in between, take the center point of that and go to the side. And I'm going to do the same with the back. But what I'm going to do is actually draw the line off to the side. Thank you, Cash. And also making them constructions. So drawing a circle on both of those endpoints. Just got to be wary of where those dowels are going to go, because potentially it might go too far to the edge. You don't want that. So I'm going to go 0.4, and then the back one, let's go 0.5, and that's more than enough. The dowels themselves are 4 mil, so I'm going to go 4.1 mil. Hit enter, and then so that I'm not dimensioning every single one, if I need to change that I can easily with just one dimension. I'm going to make those two equal, and we're going to cut actually into both the fretboard and the neck at the same time. So if we hit solid, I'm going to select those two dowel positions. I'm then going to go to symmetric and the whole length, and then I'm going to put in, or in fact I'm going to do 2 sides. Now the reason for this is because we can control each side, and we can vary sort of where that joining distance is, because if it's really long you want to put more into the neck as opposed to the fretboard. So on, what side's that? On side 1 I'm going to do 2 millimeters, and on this side I'm going to go 4 millimeters because our dowels are 6 mil in length. And then obviously at the moment, because it's only the neck is visible, it's only going to cut the neck. So once I'm happy with those offsets, I'm going to show the fretboard at the same time and then hit OK. And it will automatically know to cut the fretboard at the same time, as you can see there, which is good. And then you can, if you really wanted to, you can take these dimensions and use them from templates, and use all sorts of different saws to get the fret positions. I'm going to use a 0.6 mil end mill because that's the most appropriate cutter I have for the job. So when we come into the cam side of it, I'm going to draw lines, and it's basically going to be a reference and trace along that same radius. But that's for the next video. So there you have it. You've got a neck, looks fretless, but it does have the fret positions. They will come later. We have the positions for the tuners, the transition. It is 2 solid bodies, and if you wanted to, you can go back and adjust all of these if you really wanted to, and make variants, making it wider or thinner at the nut and heel. You can change it for all different types of truss rods, but for this I'm happy with it. So the next video will be on the body, which will be a little bit easier, as it's just sort of removing the material for where all the electronics and pickups go, which is easy. So I'll probably crack on with that today, because otherwise it's never going to come out. So if you've enjoyed this, please like, subscribe to the channel. It does mean a lot. If anyone's got any queries or issues, I'm more than happy just to Zoom call someone and kind of guide them and give them a helping hand to get to the finished result. This can be quite daunting. Hopefully this has been a nice sort of tutorial into how to do a guitar neck without all the complicated surfacing skills, because I've given that to you up front. But until next time, thank you and bye.